Hello everyone, I am Sudhir and Pujari, and in this presentation I will be covering the Python Lab assignment that is a part of my PG Diploma course. Let's look at the agenda of today's presentation, that is understanding the problem statement and solution approach, that is brute force method and two-pointer approach, and finally Python implementation code for this problem statement. Let's see the problem statement where we need to find two elements in a given list whose sum is closest to 0. For example, you are given a list -4, 7, 6 to -5. In the given list, the two elements with the sum closest to 0 will be -5 and 6. Next, in this slide, we will be explore the initial approach known as the brute force method. This method employs the nested loops to systematically iterate through all the potential pair of elements within the list. For each pair, the sum is calculated and compared to keep track of pair with the smallest sum. Finally, the element constituting the minimum sum are printed. So, this slide presents the Python implementation of brute force approach. Initially, list named a list is defined containing a set of value, while the variable list size denotes the size of the list. And next, we encounter the sum in function. It began by verifying whether the list contains at least two elements. If not, it print invalid and terminate. Inside the function, the variable for the indices and some of the element within the minimum sum are initialized. Subsequently, nested loops are employed to compare all the possible pair of elements within the list. Whenever a small sum is found, the minimum sum and its corresponding indices are updated. Finally, related to the minimum sum are printed. To execute this code, the sum_in function is invoked. With the list and list size variable, this concludes a concise explanation of Python implementation. Now let us delve into the second approach known as two-pointer method. This technique involves sorting the list in ascending order and utilizing the two pointers that move towards each other in order to identify the pair with the sum closest to 0. This slide provides the Python implementation of the two-pointer approach. The code commences by sorting the list in ascending order. Subsequently, variable for the left and right pointer as well as the variable for the minimum sum and the corresponding pair are initialized. Following this, it checks whether the size of the list is less than 2, and if so, it prints invalid input and terminates. Inside a while loop, the current sum of the element at the left and the right index is calculated. If the absolute value of the sum is smaller than the absolute value of the minimum sum and the pair are updated accordingly. Depending on the sign of the current sum and the left or right pointer is adjusted. Finally, with the pair of sum closest to 0 is returned. In the main section, a list is created and its size is determined. And finally, find closest to sum of function is then called and the resulting pair is printed. In this slide, we will discuss the pretend data structure utilized in both method 1 and method 2, which is in the input list itself. The list serves as the container for the number with which we seek to find the sum closest to 0. Edge cases to consider. Now let us address some important edge cases that should be considered when tackling this problem. We will explore scenarios such as empty list with a single element, and list with a duplicate element and list containing solely of negative or positive numbers. In the next slide, evaluation of approach efficiency. This slide evaluates the time complexity of both method 1 and method 2. Method 1 possesses a time complexity of order of n square root of 2, while method 2 operates at a time complexity of order of n log n. We will discuss how these complexities impact the efficiency of code. Let us now assess the space complexity of both methods. The both method 1 and method 2 exhibit a space complexity of order of 1, indicating that they utilize a constant amount of additional space regardless of the input size. And next we explore the efficiency of the approaches when handling the large input. That is, method 1 is not well suited for such cases due to its quadratic time complexity, and conversely method 2 with its employment of the two pointer technique and logarithmic time complexity proves to be efficient and highly suitable for large inputs. And let's look at for the final conclusion. To conclude, we have discussed two distinct approaches to solve the problem of finding two elements with the sum closest to 0. Method 2. The two-pointer approach is particularly efficient and well adapted for large inputs, and it exhibits a time complexity of order of n log n and a space complexity of order of 1. Thank you for watching. Hope you like it.